Hey there. Pre-calc, let's see, this is part 2, going over the homework for Unit 2, Lesson 9. We're picking up with number 9 here to do as a standalone problem, just because this is a key problem going over graphing it, where we really should slow down and look at like the different details of what are we going to have to do to get the correct shape for this graph. By hand, we can't use a graphing calculator tool here. So what we can do, though, we can use a regular calculator. We can use our noggins and everything here. So x-intercepts, that's looking at the top here. Factored form, if I took this and rewrote this in factored form, just to speed things up, that would be, let's see, the top would factor into an x minus 3 and an x plus 1. This is a step that you got to do. You have to end up looking at these and quickly factoring them. This is the difference of squares, so that's going to be an x plus 3 and an x minus 3. That's great. Now, we see that we have two terms that cancel here, this minus x minus 3 on the top and on the bottom. All right, and that's going to be one of the wholes. All right, so there is an element of graphing this where we're going to kind of want to make like a little mini x and y table to help determine some of the behaviors of the graph. So I'm seeing one of the values here is that if we put a value of 3 into the function, it's a value that we can't allow to happen. That's going to end up being a hole. All right, but there will be a y value that it approaches. So what we might do is we might do a value that's like close to 3 and a value that's close to 3 on either side of it. And the same thing with the vertical asymptotes. When we look at the vertical asymptotes are looking at the factors on the bottom, on the denominator, that it can't be equal to. And so that would be at x equals negative 3. That is undefined, all right? So that is a vertical asymptote. That is undefined. And we can actually map that one in. Negative 3, put in our dotted line, great. That's gonna be something that's right there that it can't touch, it can't approach that. It can approach it, but it can't touch that. So vertical asymptotes, that's taken care of. The hole is kind of taken care of, but it does say an ordered pair, so it's kind of like what's the other part of that number? We'll revisit that. X-intercepts. So the x-intercepts are the values up here where the y value would be equal to 0. Where the y value would be equal to 0. And so we would get that when we put in a value up here that would make the top equal to 0, but not the bottom. So a negative 1, all right, so right there is an x-intercept. Negative 1. That's a point that we can lock in. Done. We graphed it. We graphed the vertical asymptote. We didn't fully graph this. There's a hole somewhere here for that. All right. The y-intercept. The y-intercept is going to be the value when we put 0 in for x. So if we put 0 in for x, what's the value that we get out for that for y? It ends up being 1/3. You can go ahead and do the math on that and do the math here. Go ahead, put 0 here, 0 here, 0 here for all the x's. Those go away, and we get negative 3 over negative 9. That reduces down to 1/3. So if we go up 1/3 of a unit, that is going to be a definite hard point that it goes through. So that is the y-intercept. Horizontal asymptotes. Now, since the degree on the top and the bottom are equal, the horizontal asymptote is equal to the a values, those leading coefficients of 1 and 1. So it would be at y equals 1 divided by 1, which is 1. So right here, there is going to be a horizontal asymptote right there. So that takes care of that. Then it says sketch the graph. Now, here's the thing. Sketching the graph, I need some more data. So I need to know what the graph does as it gets closer to this line here. So I need to put in some values. It would make sense to put in a negative 2. Okay, so we know where this is, and I feel like that this is dipping down, but I want to confirm that. It also makes sense that I put in a value over here just to kind of confirm that it's like approaching this. I can see that, and that's what my brain wants me to do. So maybe I put in a nice number like a 10 or something like that. And I'm trying to pick numbers that maybe I could work with in my head. Negative 2. So we take this and we do negative 2 squared. Well, that would be 4. All right, and then negative 2 times negative 2 would also be another 4. So we're adding another 4 to that. That's going to be 8 and 3. So 8 and 3, 8, 9, 10, 11. We got 11 up top. And on the bottom, if I put in negative 2 and squared it, I get 4. And I would have 4 minus 9, that would be a negative 5. Yeah, and what is 11 divided by negative 5? Yeah, negative 2. Okay, so negative 2 and a fifth. So if I go to negative 2, I get negative 2.2. So negative 2, I go down negative 2.2. That is where my point is. This is confirming that the behavior for this graph is doing this, and it's going to approach this vertical asymptote like that. I want to confirm that it also does this over here, so that's why I'm picking a number that's way out, like 10. I feel like we'll get an answer that's close to 1. Put a 10 in here. 10 squared, that's 100. Okay, let's keep track of this. We're going to have 100 minus 2 times 10, so minus 20 minus 3. We get 77. So I'm just going to scratch paper this. 77 gets divided by 100 minus 9. Okay, so 91. All right, so 77 divided by 91. Well, that is close, getting closer to 1 whole. Remember this horizontal asymptote, but it's at 0.8. So all the way here at 10, way over here, it's going to be at 0.8 something. So it is approaching this line. It is approaching that, okay? Okay, so we have this part of it. Many times when you have something that's doing this shape, you have something that's kind of going in the other concave shape. All right, but I want to confirm that. I need to put in a number that's kind of close to negative 3, but it's on this side of it. So like a negative. So again, I'm picturing this and I'm saying, what if I put in negative 3.9? And we do the math on that. And then what if I put in a number that's further down this, like a negative 10? All right, so 0.8 something, blah, blah, blah. So what happens to this as we do that? Let's do the negative 10. That's going to be kind of nice to work with. Negative 10 times negative 10 is 100. And negative 10 times 2 is going to be 20. So 100 plus 20 minus 3. All right, 100 plus 20. Oh, my God, a minus 3. Yeah, we know it's 117. All right, so the numerator would be 117 if I put in negative 10. And then negative 10, if I put that in here, square would be 100 minus 9. Wow, there we go. We got our 91 again. And so we'd have 117 divided by 91. That's going to be a little more than 1.28. So here's what we're seeing is that as we go further and further out, it's going to be a little more than 1. All right, so the graph is going to get close to 1, but not touch it. All right, so that's what we get at 1.28. Honestly, it's not going to it could cross this locally. So we should check one more and just make sure that as we're getting closer to this, how about instead of like 3.9, we do a negative 4. That should be a little nicer to work with mentally. So negative 4 times negative 4 is 16. And negative 4 times negative 2 would be positive 8. 16 plus 8 minus 3. There we go. We got 21 would be our numerator. So 21 would be our numerator. What's the denominator if we put in negative 4? Again, we'd get 16, but we'd have 16 minus 9. We get 7. 21 divided by 7 is 3. That's nice. So if I go over to negative 4, my value would be 3. So we had a value that's close to 1, a little more than 1, and the value that's high, that's confirming that it's going to have this shape. It really is. It's not confirming that it flips and goes down here. I'm not getting any inkling that, like if I got an answer from this and it was down here, then I might think, oh, it's doing some weird thing up here, but no, it's not. So this is our final shape. That's 9 minutes going over one problem, but this is the detail. Looking at how you have to make like a little table like this is a tool. Some people can kind of do this stuff in their head, but this is definitely a tool that can help you break these graphs apart. Take care.